Hello, this is our first C++ video. I will be doing Chapter 2 from starting out with C++ Early Objects by Gaddis, 9th edition. I'll be doing this chapter by chapter as a review/preview of stuff done in classes that I teach, in courses that I teach. If you'd like to learn C++, I would strongly suggest you get Gaddis's book because he is an amazing, very, very clear author. I will be doing examples from this as a review/learning experience, explaining as I go for each chapter. Obviously, starting with Chapter 2, as we're here, Chapter 1 is just an introduction to computing and things, ideas. This is the Visual Studio compiler. You can get this for free. This is Microsoft Visual Studio. You can download it. There is free versions of it online. You just go to Microsoft website. You can Google it. Some computers have a little bit of trouble. I had a really fair amount of trouble doing it, which is not so untypical, which is not so atypical, sadly, to do this. But there are other C++ compilers like Dev Bloodshed and others, and you can just Google those as well, C++ compilers. There are many free ones, but this is the setup. I just opened a new project, and I am filling this in. Now, a couple quick comments that we need to know about C++. One, if I would like to make a comment, you'll see it's in green, and you use the // okay? So I am telling you that this is a comment, and slashes, double slashes are for comments. Double slashes are for comments. There are other ways to do this, but for now, that's perfectly fine. You could put it anywhere in the program. The compiler knows not to run that. Now you'll notice after that I have all these I have the hashtag include statements, stdafx.h. That's so this compiler will work with other compilers and other code, but that is just going to be for Visual Studio. You don't necessarily regularly need that. But you do need to include preprocessor directives, which are things that need to be uploaded first in order that the program can run and know that they're there. So include IOStream in the brackets over here is going to be something that I'm going to use C in and C out for, which is how I can get information back and forth from the computer. There's lots of these things. I'm not necessarily using all of them. I'm just telling you what libraries I basically want to include. For instance, I want to include the IOStream, math. So I want to use math functions, maybe. I will, maybe I won't. I'm not going to tell you. I don't know. String. If I want to use this thing called string, I have to bring it up. Whatever it is I want to use, I have to include it ahead of time. Okay, so not a big deal. Whatever program we're writing, include it ahead of time. Fine, end of story. Using Namespace Std. Okay, this is our standard library. This is something that is going to basically tell us that when we want to call something from these libraries, it'll figure out where it's from, the typical place where it's from, instead of us having to tell it, oh, it's from this area, and then zoom down into this thing. You know, in other words, like, it's in this big book, and then it's on page 7, and it's in the 3rd line. You know, we can say the word, and we'll figure it out. Now, int main. Main is a function. Main is going to be where we're going to write our program. It has a return 0 because we are required to return stuff from this setup. Every program has to have a main. Now, the initial stuff that we could do, obviously, well, not obviously, but if you're not into programming, but we're just going to see out hello world. Okay, now let's explain a little bit about this. Hello world, see out, hello world. See out is going to be our outputs. We output. We have these operators here, which are hefty duty operators, really. There's 13 plus overloads on those guys. In other words, they can do more than one job. And in quotations, we have hello world, and it says it's constant char of that. It's a string. A string just means a bunch of letters together. At the end of it, there's a semicolon. At the end of return 0, there's a semicolon. Anytime you do something in C++, in Java, in different languages, not all, but in many, the semicolon is going to tell us it's the end of the line, okay? Now, cout is going to output it to the console. So if I say debug, start without debugging. Take a second. Okay, it's going to go soon, maybe. It says, hello world, press any key to continue. Okay, so this is the console, cmd.exe, and it outputs it to this thing. I'm just going to press a key and it continues. So my hello world was outputted with cout. Now perhaps I want to have it so it doesn't have that in the same line. So I'm going to do a \n. Okay, I never honestly remember which direction the backslash goes. Is it backslash, is it forward slash? But I'll run it and test it just in case. It's once you get to higher programming, that's not the way to do it. But okay, let's see. What's the difference over here? It says hello world with a \n means just go to the next line. So you can see from my code over here what's the difference. It says hello world in one line, and then it says \n, which means just go to the next line. So anything else is going to be afterwards. So okay, that's our hello world program, and that's, you know, that's what you need to know first. Now we could do a lot of things. I'm going to just erase this, and I'm going to write some other stuff over here. We could create lots of different numbers and do addition and subtraction, multiplication and stuff. But we have to tell the computer what we're talking about. So I could have a variable that's going to be an integer. So I would say int, and let's call it var1 equals 5. So var1 equals 5. 5 is going to be assigned, because the equal sign doesn't mean equals, it's an assignment operator. var1 is going to be assigned, 5 is going to be assigned to var1, which is an integer. An integer is something that takes up 4 bytes, and that means bytes, meaning there's, you know, 8 bits, right, per byte. You're going to have -2, let me see, I have it right here in front of me, -2 billion to about 4 to +2 billion, about. That's how many numbers an int can deal with. There's different types of things that we could use. For instance, we could use something that would just be positive, which would be an unsigned int, or something like that. We could use a long var2 equals 3, 4, 5, 3, 2, whatever. Okay, notice the semicolon. That's a long is just going to be bigger. Long goes from more. But let's just say more. Now you could do, they have lots of data types. In fact, there's this thing called a double, which is going to be double the single precision. And a double var3, a double can handle things like this. Okay, what's the difference? An int is only integer, positive or negative, number. However, double var3 is allowed to hold things that are decimals. So double was made in order to hold things that are decimals, and we'll use it like that. We could say something like int a, b, c. That would just be creating them. We didn't assign anything to it. We could say a is 5, and b is 6, and c is equal to 7. And then I could say something like var1 equals a times b times c. Now, and I'm going to cout var1. So let's talk, and then I'm going to do inline. So let's talk about all of this stuff that I just threw in there pretty quickly. We could create a variable and assign it. There's lots of different data types, which means how much memory is assigned to it and what type of memory is assigned to it. Double var3 is a double is allowed to have decimal points. Okay, double is allowed to have decimal points. Int abc is 3 different variables that were created. Those variables that were created do not have any assignments. Afterwards, I assign them. Note A is going to be assigned 5 with a semicolon, B is assigned 6 with a semicolon, C is assigned 7 with a semicolon. Okay. Now, var1 equals A times B times C. I'm taking var1 and I'm reassigning it something that I'm doing with math, which is A times B times C is going to be var1. I'm reassigning it. So it used to be something, used to be 5. Now it's going to be something else. Okay. It is an integer, but that's okay. Cout is going to display it. Then I have these less than signs, okay, which are operators. But var1 is going to be the thing that's going to be output, right? I don't have to have a string in quotations. I could actually have var1 as is. It's just going to be the number. And then nline after this thing over here is going to, after the stream insertion operator, is going to, nline is going to give me a space just like the \n did. Okay, So let's try this and run it. var1 is going to be reassigned a times b times c, semicolon, which means that's the end of the line, cout less than var1, which is a number. It's going to output that, and let's run it. So let's go to debug, start with that debugging, and let's try it, see what we get. 210. Press any key to continue. Great, thank you. Okay, so those are some numbers, those are some outputs. Let's try and play with this a little bit more. Okay. There are these floating type data points that are available. There's single precision, double precision, and long double precision. Float is for single precision. Usually it's stored as a double though, so we'll deal with that. Float, and I'm going to say distance equals, and I'll do this example, 1.49 e to the 8. Okay, I'm going to say double mass equals 1.989 e to the 30. Okay. Now, we could input these into a statement. So we could say cout less than the sun is, and because this is a statement, I'm going to have a little less than, and now I'm going to say distance. So it's going to say the sun is, and then it's going to say the number. And now I'm going to put in something else. I'm going to say space kilometers away \n, because I want a new line here. And that's going to display the sun is, however big this, whatever distance is, and then kilometers away, new line. Now with this new line, I'm going to say cout the suns. Now there's a little bit of an issue, which I'm going to do this for, and I'll tell you soon why. But for now, just leave that \. there. The sun's mass is, and let's do the same thing that we did before, which is create a little bit of a space. Put the stream insertion operator there, less than signs, mass less than kilograms \n, and period. Well, we could just leave. We did a period already. And end line. Okay. So what did this do? What this did is it's going to say the sun's mass is. If you had the semicolon, let's just run this first. Okay. It says the sun is E49 plus 108 kilometers away, which is distance. So it's displaying it that way. You could have actually written 1.49 E plus 108. It doesn't have to be uppercase E. It could be lowercase e. It could be with the plus, without the plus. Lots of ways to write it, but it's just a big number, right? Because E is just to the power times 10. So it's just a big number. The point is that we could deal with big numbers. The sun's mass is mass kilograms, the sun's mass. Now, you'll notice that it doesn't say \. here. Here it says sun's mass. So let's see what's going to happen if I take this away. Okay. Not promising anything, but it says sun's mass is kilograms. Now, the reason why I'm able to put that in is because it's going to tell me that it's a apostrophe, just so I don't get any errors if I were dealing with other things. In this case, it's actually perfectly fine, but not necessarily always is that true. Now, just some technical points. These are strings. We're putting them, then displaying the number, then displaying more strings with an end line. Okay. Float, it actually doesn't save a float as a float. It actually saves it as a double. So if you wanted to do something, like if we wanted to say, like, 149 whatever e to the whatever, if I say f afterwards, that's going to force it to be a float, but the compiler may not even like that. Okay. There's other issues also with other types. So if I were to say long amount equals this number, whatever, I could force it to be a long as well, and I could say long, because there is a data type called that, which is very big. There's one called long double, which is is going to be just bigger than double, but that's just essentially what it is. Now, that's another data type. So we talked about ints, we talked about doubles, okay? And we're trying to output them to the screen, practicing that. Okay, another data type, char, letter equals a, okay, semicolon, char, letter 2, has to be one word, so in char letter 2 equals big A, all right, and string Bob equals what's up, semicolon. Okay. Now, you can't use the string unless you include it up above, which I've done already, so I'm just doing that. Now, it says char letter A in single quotations because a character or a char is an A. How is it saved? It is saved as Unicode, which is just numbers. So it interprets this A as a number, really. So char letter A is that. So I could say, right, I'm going to say something like letter equals, I'm going to assign something new to letter. I'm going to say letter equals letter plus 1. Okay, see out letter. Let's see, end line, that way it's going to go to the next line. Let's see what we get. So A is a number, really. That's why I can add 1 to it. So let's see what we get when I say debug, start without debugging. Yeah, this is, okay. It says B, because when you add 1 to A, you go to the next letter. Now, how is it? I'm adding 1. Does that make any sense? Yeah, because you can add 1. Now, if I were to add 1 to big A, that would, what would that do? That would go to big B, because they're not the same thing. Okay. Now, those are only single characters. That's why they're chars. I took letter, which was A. I added 1 to it. I got B. I assigned the B to letter. And then I said C out, less than letter, end line, so it's going to go to the next line. String Bob, what's up? Now that's a bunch of things all together, and that's going to be something that's a string, which just means a bunch of characters all wrapped next to each other. The only difference is really that the A is saved as an A, and that's it. However, the string, what's up, is saved with all these characters, each in a position in an array, whatever that means, with a end character at the end. So even if you had A like this as an array, it would be different than the A right here. Let's make sure this works. It would be different than this A, the way it's saved, because this is actually saved as a string, meaning a long list of an array string of A with the end, with the position that says that it's the end of the array in order to tell the difference between those things. So we have that, and that's a string. Okay, that's another data type. So we did int, we did double, and we did char and string, because they're pretty related. Okay, let's see another data type. Let's try a bool. Bool, Boolean equals true. Bool and Boolean equals false. A Boolean is a true or false statement. A bool is the data type that tells us about that true or false thing. So, that's just what it is. I can't really, there's nothing to expand on. But it's very, very useful. And I'm not going to tell you why right now, because it's going to be worthless. However, let's look at doing some math and stuff like that now with this and talk about things. So I'm going to say int A equals 5. Int B equals 7. Int C is not going to be assigned anything yet. What am I going to do with it? I will assign it, actually. I will say that is going to be B divided by A. Okay. C out, C, end line. What's that going to give us? 7 divided by 5. Well, if I say start without debugging, it's actually going to give us 1, because 7 divided by 5 is 1 with something else after it. But because these are integers, remember these are integers, A, B, and C are integers, we don't care about the something else after it. All we care about is the integer part of it, because C is an integer. A and B are integers. If I were to change one of these two, if I were to change these to doubles, I would have to change this and at least one of these, and at least the C and that. Now, b divided by a, an integer divided by double could give you a double, which means that it could have decimal spots, so it'll be 1.4. So that's one way to deal with it, which is change it to a double. If this were an int as well, if a were an int, an integer, and b were an integer, 7 divided by 5 is an integer divided by an integer, gives you an integer. That's only 1. However, I could do this thing and say double, which is going to convert the b into a double. You can do that and convert the b into a double, and now you can display it. Now, what would happen if I tried it like this, with c being an int? Well, it's going to convert it to a double, but it's going to switch it back to an integer because c is an integer. So we don't want that. We want to make sure that we can display it and try all the variations out. Just write this code and print it, or output it and see. Now there's a really good operator. Okay, so that's just some points about arithmetic and stuff like that. There's a really important operator that's called mod. So I'm going to leave this, and I'm going to say int c. It doesn't matter if it's an int or not, because modular is always that. Int c equals 7. Funny, silly sign for percentage sign 5. Now that is the sign for mod. That means what's the remainder after division? That's the remainder. So 7 divided by 5 has a remainder of what? 2. So let's assure ourselves that the output is going to be 2, and it is. The output is 2. So if you want to know what the remainder after division is, that's what it is. So if you wanted to figure out, well, how many minutes are left, after something happens, how much is left over after I did something, that's the way that you would find out by doing that. So that's our introduction to C++. We talked about data types, which is the type of thing that's stored there. We did a little bit of math. We assured ourselves that we could put in comments wherever we like I could put a comment right here. Tab. I never remember which direction these are in that way. Here's a comment. Oh, I assign 5 to A. Okay, so comments don't need any semicolon, everything else does. But that's a comment explaining my code, and you put comments in to explain your code wherever you can, because that way when you look at it later, you know what's going on. So this is the chapter 2 in Gaddis. Pretty straightforward, right? We have int. We have, let me show you a bunch of them. Double B. We have long L. We have long LL. We have float F. You could assign these things. I'm just showing you data types. Bool B. We have char C. We have string, which S, which is not colored in. You'll notice because it's colored in differently because it's really a class in C++. We have int, double, long, float, bool, char. What do they do? Int is an integer. Long is just a lot more information. Float is precision. It can handle things that are pretty big. Double is double that, and long double, LD, is even more than double, and depends on the compiler. And bool is true or false. Char C is a letter. String is a word. And long double, like I said, is a lot of stuff. Now you say, "Ooh, what do we do?" Well, we did actually quite a bit of stuff that you could really figure out at this point. That you can build things, and you can output stuff to the screen, and you can do math. And that's a pretty big deal to be able to do something like that, to do math and to do whatever it is that you like. Like you could have, you could do all that stuff. So that is our first video. That is chapter 2. We'll be doing more chapters as we go.